We are live. Today we are talking about stoich. So S-T-O-I-C-H, also known as stoichiometry. All right, stoichiometry. Two ways I like to define this is a mass to mass relationship. So one mass of something, I can convert it to a mass of something else. Or I could take liters of something, I could take it to liters of something else, but usually it's mass to mass. And stoich must follow the law of what? Yes, that one, Maddie.
Oh, you heard me?
Yes. Conservation of matter. It must follow the law of conservation of matter. So I could ask you something like this. Do you guys have your yellow sheet and your calculator? You're going to need that. How many grams of KNO2 are produced when 17.29 grams of KNO3 decompose? So I could ask you something like that. How many grams of KNO2 are produced when 17.29 grams of KNO3 decompose? What is going to be your first step in doing this problemo? First step's going to be what? We need an equation, right? So, did you learn last year in CP Chem that if you have an 8, which you guys would agree that this is potassium nitrate, we're decomposing it. This is potassium nitrate, right? If you're decomposing it, 8 always goes to the ite version plus O2. Did you guys learn that last year? Well, you should have. All right? Anytime you're decomposing an 8, it always just goes to ite plus O2. So if you remember that, you will be able to write the decomposition for this.
Next to 17.29.
When?
Okay.
Yeah, obvi. So I have KNO3 is going to decompose into the ite, which is potassium nitrite, plus O2. So there's my equation. Is it balanced? It is not balanced. It is not balanced. So what am I going to have to put in front of this compound? A 2. It gives me 2 Ks. So what am I going to put in front of this compound? A 2. Is that balanced? I've got 6 oxygens. 2 times 2 is 4. 4 plus 2 is 6. That looks good.
That's great.
What I like to do when I'm working on problems like this, I like to write what I've got. So I'm starting out with 17.29 grams of that. And I would like to know how many grams of that. When you do this, it just makes it a little bit more visual. You guys don't have to do that. But I think it just helps. Helps writing out where you're going. So here we go. Let's run our line of stoich. So I'm going to start out with my 17.29 grams of KNO3. How many sig digs will my answer have? I already know. 4. Because however many you start with is however many you end with. This means that the electronic balance I measured to the 0.1s, so then it went to the hundredths. Okay, what is the molar mass of KNO3? Potassium nitrate, yellow sheet. 101.102 grams of KNO3 in 1 mole of KNO3. You can spell mole, M-O-L, or M-O-L-E. Either one is okay. Either one is okay. Did I ever tell you guys a story about my date at the fair on the zipper?
I don't think so. No. Did you throw up?
No. So this was not the person I'm married to now. I was on a date, and I can't say names of these people anymore because now there's people I have that I went to school with, their kids. So I'm on a date with this girl. We're having a great time. We get on the zipper, and you guys ever read the zipper? There's it goes like this, The cages go like this on that, and then the whole thing's also going like this. So if you rode the zipper, it takes a while to load you on, right? They load you, then they move it around, they load the next person, they move it around. So we got loaded on, me and Chris, sorry.
Christina.
Yeah, that was her name, it's fine. Doesn't matter. Anyways, no one's mom here is Christina, all right? She does not live in this area anymore.
My mom.
Christina Matthews.
Really?
No.
No.
Christina Matthews was my Spanish teacher, so it's not her. Yes.
That's kind of crazy.
No,
Why'd you go on a date with her then?
I didn't.
Wow.
No. No. Anyways, so me and this other Christina, all right, are on this zipper cage, because it's essentially a cage. As we're getting ready to ride, somebody puked above us, and it rained puke down on us before the ride started. So then, like, there was nothing we could do. So, like, there's puke, like, going, like, we're going like this. There's puke occasionally hitting us all through the ride. And that was the omen I needed. That was our last date. All right? It was an omen. Hadn't even started.
That's kind of
Yeah.
I would they would want me to get ready off the ride.
Nope.
That's a great memory.
Yeah. That was the omen I needed. That was the omen I needed.
Well, I just know Ellis.
I don't think I have. I don't think I have. All right. Stories, guys. So many stories I think of. All right, the next step is the most important step. What is the next step called? The Stoic step. I know that for every 2 moles of KNO3, how many moles of KNO2 do I have? 2 moles of KNO2. So I'm going to box that. You guys don't need to, but I'm just going to start in my notes so we know that that's the most important step. Stoic step helps us go from one thing to another. And I know for every 1 mole of potassium nitrite, how many grams is KNO2? Yellow sheet.
Dude, it's not with the other ones.
It's not on there? It's 85.103 grams
Next to KNO2.
of KNO2. So solve that. Tell me what you get. Put that in your calculator and make sure you guys can do this. Or just watch and wait for someone else to do it. What do we get?
Calculate that.
I got it. Joe's got it over here.
We have 14.55.
I got it. I got it.
Do we have a confirmation on 14.55?
I got it.
Yeah, I got 14.
Okay. I would accept 14.562, 14.55 grams of KNO2. So make sure you are writing everything. I want the answer, units, and the label. So answer, units, grams, label, KNO2. KNO2. Can I flip my page? Okay, let's do something with this. So, I will ask you, I may and I will ask you something like this. How many grams of calcium chloride, so let's get very chemistry-y here, chemistry-y, how many grams of calcium chloride are produced, and how I write this is important, when 33.29 grams of iron 2 chloride, I told you we're getting very chemistry here, chemistry-y here, iron 2 chloride completely react with excess calcium hydroxide. So we have a loaded question here. And I have also told you a lot. What have I told you so far? I've told you grams of something. Told you that.
How many? Just start with a number.
True. Sorry.
Well, too.
Thank you. It was.
Really? I actually didn't. I didn't quite the sneak.
It was.
There's quite the sneak. Couple less. Extra sneak.
Extra sleeves.
Wait.
What else have I told you?
How's it
With this word right here. What is that word? I told you complete and I told you excess.
Wait, is that double?
I've essentially told you that iron 2 chloride is my what? Limiting reactant. Which means I don't need to solve for a limiting reactant this time because I said iron 2 chloride completely reacts. If iron 2 chloride is all the way used up, you would agree that's the limiting reactant. Yes.
That's so small.
Yes. So, step 1, write your equation. Do that. Write your equation. What type of equation is this? Going to be double displacement.
Double switch.
I've got leftover Giannino's for lunch. And a Mountain Dew. 'Cause-
Mr. Miller, I may have had over 2 dozen of that so far.
really? I run a mile for every donut I eat, so it's like a penalty. So that helps me to keep my donut totals down.
Yeah, just, yeah.
Yeah, well, it's fine. I feel like your metabolism is a little faster than mine at this point.
Yeah, just a little bit.
Do you have white out?
I do.
Thank you.
Good so far? Yes. Why is there a 2 where?
Oh, because it's a minus.
Oh, this is hydrox.
Yeah.
Hydroxide OH is a minus
I
1.
thought it was hydrox.
Hydroxide.
That's not what I was.
Like, I thought it was the one that's just off hydrogen. But then that would make sense because it is. Okay, it's never mind. It didn't come out. Just-
Great job, Dan.
I know what I did.
Okay. As long as you're good with it. As long as you're good with it. I have 33.29 grams of this. I would like to know grams of CaCl2. Is it balanced? Yes, it is. Yes, it is. So, run it. Run your line of stoic. I'll give you guys a 2-minute head start. I know. It's very problem solving, it's very process. Yes.
Just write it out. It is nice.
It's so quiet in here. I know, you're locked. Have you guys seen any of the videos on social media of people cutting their own like bangs?
Yes. Me too.
I live
Me
off of
too.
those. I literally live off of those.
Yeah, those are
I put one in my sink last year and they like turned out good though.
okay.
I cut mine when I was like 3 or 4. I hid behind a table in my old house and I cut them all the way up here because I didn't want my bangs anymore. And then my parents like every day they like saw me get shorter and they're like, and then they found hair behind the table and then like I came up one day and they were about this. They were like, you know what? And now I want to be a cosmetologist when I'm older, so it kind of.
There you go.
You do?
Yes, I figured myself out.
You got there.
I know I'm about there.
I just like it when like it's a guy and they like end up with like the bowl cut. It's like this and like they just go all the way around.
This is gonna be professional bullshit.
No, oh yeah.
Obviously.
That's my study.
Do we have an answer?
Yes.
Derek, do you have an answer?
No, I didn't put it in the cabinet.
Okay, that's fine. Daniel, do you have an answer?
Not yet.
No. Kevin, do you have an answer?
Yeah,
What'd you get?
29.15 grams.
Can we confirm 29.15? Okay. 29.15 grams of CaCl2. Beautiful.
Those are so fun.
Beautiful. Okay, so what is a limiting reactant? What is a limiting, how would you guys define it? I like that. The limiting reactant is the reactant that runs out first. Or you could say it's the reactant that limits the reaction. But you shouldn't use the, you shouldn't use the word in the definition. The excess reactant is what?
What's left?
The excess reactant is what's left over. What's left over? What I have left over. So if I had the following, if I had 3 monster truck bodies. Did you guys do this with Mr. Ruff last year?
Probably not. We didn't do a lot of stuff.
Okay.
Walsinger did it.
He made the monster trucks?
Oh, wait, no.
Oh.
I thought they were
We didn't have one.
Okay. If I have 3 monster truck bodies and I have 14 wheels, and I ask you, what is the limiting reactant? What would you say?
Monster truck.
The monster truck, the bodies, right? The trucks. Can I say the bodies? What do you guys want me to say? The trucks. The frames.
Yeah, that's good.
The limiting reactant is my frames. And what is my excess? Wheels. The excess is my wheels. And if I asked you, how many excess wheels did I have, what would it be?
2.
2. How did I know that? Well, I'm going to start out with my limiting reactant, right, which is frames. For every 3 frames, I need how many wheels? 4 wheels.
What about spare tires?
No spare tires. No spare tires. No spare tires in this situation. What? So a Segway? I guess the Segway has 2. Or like those things that the guys ride with like their remotes.
What if it was a dually?
Okay, have you guys seen those guys that ride those one-wheel things with like their things that like
Yeah.
they go over here at the by the police station? There's like that hole. They ride down into that hole.
Wait,
Yes.
you like tilt it and it's like
Yeah.
It's crazy.
They're always cruising around.
Those things like are off-road.
no.
That's
My daughters and I were actually sledding in that little hole last year, and those guys came and just were going through the snow. Yeah. So they're cool. They're cool. All right, we're gonna come back to this example in a second. How much space do you have left on your page? Okay, if you write small, you're probably good. If you don't write small, you might want to turn the page for what we're about to do. Because this is a lot. This is a lot.
what is it, like a whole page worth? Or?
I mean, you could probably fit it. You could probably fit it. You probably want this example all on one page.
So this is enough.
Yeah, for sure. Probably, yes. I just write big. It's annoying when like this gets split between 2 pages when you're looking back. All right, I'm gonna write you a balanced equation. So I have 2 FeCl3 plus 3 CaOH parentheses 2 yields FeOH3 plus 3 CaCl2. So let's say that we start out, I'm not going to write out a bunch of words now. Let's say that we start out with 72.16 grams of iron 3 chloride. And I start out with 34.17 grams of calcium hydroxide. And I would like to know how many grams of calcium chloride can that form?
Should we get 2 for the iron compound on the yield side?
Here?
On the other side.
On the other side.
Nope, because hydroxide's a 1.
I meant
To balance.
to balance it. Like-
2, 2, 2. Yes, thank you. There should be a 2 there. Coefficient of 2. Yes. So I could ask you the following. I could say, what is the limiting reactant? I could ask you how much is produced in theory. How much is produced in theory? And I could also ask you how much excess is there? So from what the information I've given you, you can tell me all of those things. Who remembers doing limiting reactants last year? How'd you do it? With this information, what would you have done?
You convert like everything to the limiting reactant.
You would have ran grams of this to grams of one of these,
Yeah.
grams of this to grams of one of these. Whichever one made less was your limiting reactant, right? There's a shortcut. There's a shortcut.
There's my brain. My brain's bad.
So you can still do that, all right? But that's not how I'm going to show it in my notes. I'm going to show you the shortcut, okay? Here's how I do it. I'm going to start out with my 72.16 grams of FeCl3. And I'm going to run that to moles of FeCl3. So I have one, you'll see why. Molar mass of that is 162.206 grams of FeCl3 in 1 mole of FeCl3. I'm going to pause that there. I'm going to do the same thing for CaOH2. So I have 34.17 grams of CaOH2. And some of you are going to think this is genius, and some of you are going to be like, I don't like this. That's fine. You can do it the old way. It will save you time, especially on the AP test if you'd have to do a limiting reactant. It just saves time. CaOH2, what's the molar mass? 74.094 grams of CaOH2 in 1 mole of CaOH2. So take a pause and solve for moles of each of those. That's a 2 right there. Yeah, I ran out of room. That bell was a little quieter. Did you guys notice that? Also, the clicking, I think, is fixed.
I haven't heard it.
I know, see, it's like railroad tracks. You got used to it.
I'm so good at them. It's so driving nuts.
And these are both to 4 days.
4 sig digs.
Those are really satisfying.
Oh, yeah.
Yeah, honestly.
I think
Well, that was right here. Here, I'll do it again, but closer. This will be like ASMR later.
I'm like, oh, to watch this.
Now you've got it. Now you've got it. Huh?
Like, on the
On the microphone?
Can you whisper it? Whisper.
We are now going to determine the limiting reactant. What'd you get for this one? Point. 4.9 moles of FeCl3. What about this one? Moles of CaOH2. I know. I now, at this point, I have enough information to know what the limiting reactant is. Anybody see it or have a guess of why?
Is it like, is it FeCl2?
I would want to know why or how.
It's
it
smaller.
smaller?
less
It has
of-
less of a mass
What'd you say?
It's a less of a molar mass ratio.
You're on the right track. So what I like to do is I like to look at the mole ratio between my two reactants. What is my mole ratio? It's a 2 to 3. Or would you agree that's also the same as a 1 to a 1.5?
Wait, it's the other one. Because.
Grady, you're saying it's this one?
Okay,
Yeah,
because if you
exactly.
times 0.46125, 1.5, or if you times it by 1, and then you times the other one by 1.5, then the other one's going to be more than that one.
He's right. So what we're looking at is the mole ratio. We're looking at the mole ratio. For every one of these, I need 1.5 worth of these, right? So for every one of these, I need 1.5 worth of this. So I'm going to take 0.4449 in my head, and I'm going to multiply that by 1.5. What is that roughly by 1.5? What's it going to give you? 0.6 something, right? Is this 0.6? That's your limiting reactant. That's it. So therefore, this is my limiting reactant. Once again, I'm going to talk that through one more time. For every one of these, one FeCl3, I need 1.5 CaOH2. So for every one of these, I need 1.5 times of this. So I'm going to take 0.4449 in my head and multiply that by 1.5. I know that's around 0.6. Yes? This is less than 0.6, so I do not have enough. Therefore, that's my limiting reactant. It's really nice when this is 1 to 1. If this is 1 to 1, guess what? Whatever's smaller is your limiting reactant. So using the mole ratio really does help you. Head nod if you're okay with that. Okay, why did we run to moles? Well, now I'm ready to take my limiting reactant and just run it to my theory. I'm already at moles. So here's my limiting reactant. So I'm going to take my 0.4612 moles of CaOH2, and you would agree I'm ready to go directly to my stoic step now. Yes? Yes. So 3 moles of CaOH2 in my balanced equation is to 3 moles of CaCl2. That's what I'm trying to figure out. 3 moles of CaCl2. Molar mass of CaCl2 for every 1 mole of CaCl2. The molar mass of that is 110.986 grams of CaCl2. That will give you how much CaCl2 should be produced in theory.
So what's the other way?
What's the other way?
This is what Mr. Ruff taught us last year.
I don't think it is what he taught you last year.
It's not.
He would have ran grams of this to grams of this, grams of this to grams of this, and see which one was less.
21.
Yeah, I got this one.
This is way shorter. This is way shorter.
Yeah, I might still do this.
51.19
It's 51.19.
grams of CaCl2 produced in theory. That means in a perfect world, without any external factors, this is how much we should get. Do we usually get that much? No. Which means we then have to solve for what? Not percent error, percent yield. So we'll do that on the next one. We'll do the next one. Now we're ready to get the excess. So in order to get the excess, I start out once again with my limiting reactant, and I'm going to run it 2 grams of what? The other one, right? I'm going to run moles of this to grams of this. Do you see why it's nice to run these to moles? It just helps your stoic. You're like already halfway through. So I'm going to take my 0.4612. So let's make a note there that I'm going to take my excess, and in order to get excess, I take my limiting reactant and I'm going to run it to the other reactant, because the other reactant is my excess. Just like we did with our truck bodies, right? We had to take our 3 truck bodies and we had to run that to how many tires? 3 truck bodies was how many tires?
14.
12 tires. And then what did I do? 14 minus 12 is 2. Now we have to do that with chemistry. I'm going to do that with chemistry. So I'm going to take my eliminating reactant, which is still 0.4612 moles of CaOH2. And in stoichiometric step, for every 3 moles of CaOH2, I have 2 moles of my excess, which is FeCl3.
Can you go down a little?
Yes, I can. Thank you. Sorry. And for every 1 mole of FeCl3, I have molar mass of that is 162.206 grams of FeCl3. So this is going to tell me what? This is going to tell me how many truck bodies did I actually use, right? So this is going to tell me how much I used. So this is not my excess yet. I will then take this number and do what with it? Subtract. Yes. So this is going to tell me that I used 49.87 grams of FeCl3 used. That is how much I actually used. If this number is greater than this number, guess what?
You had the long.
You pick the long limiting reactant, right? Because that's impossible. Because this number minus this number should be a positive number. This number minus this number should be positive. So that's a good check step on if you got the wrong limiting reactant. So I'm going to subtract my 72.16 or my 12 truck bodies, 72.16 grams of FeCl3 minus how much I actually used. So I only used 3 truck bodies, so 49.87 grams of FeCl3, and that will give me my excess. That's monster truck chemistry. That's monster truck chemistry right there. How many after the decimal will my answer have?
2.
Why?
Because sick days.
Which is, how many after the decimal in this number? 2. How many after the decimal in this number? 2. So this is going to have 2. Because when you subtract, it's the least amount after the decimal. That was weird. I just saw a hand. I heard that Lydia Dunlap got Annie. Is that true?
It's true.
That's so exciting for her.
Yeah. That's gonna be fun.
What'd you guys get?
22.
22.29 grams of FeCl3 excess. Okay. Are you ready to run one on your own? All the way. Can I flip my page?
Yeah.
Okay.
I'm not getting your page.
I did.
Here we go.
Wait.
Look, is that this? No, it's I don't.
How many grams of barium phosphate? Barium phosphate. That's just fun to say. Barium phosphate. Doesn't that sound scientific? Are produced when 61.32 grams of barium chloride, 61.32 grams of barium chloride react with, whenever you see the word react, what are you thinking of in a balanced equation usually? The react is usually the plus, right? It's your plus. With 27.29 grams of phosphoric acid. Do you see how there's like 12 places where you can make a mistake on this? Starting with what? Just writing your formulas out right. Yes, even before the equation, just writing your formulas. Also find excess. Also find excess, because you can't solve this without determining the limiting reactant anyways. So I will give you guys 5 minutes. What? What's that? What'd you say, Danny?
Rose class should get 5 minutes more on every question.
Oh,
Yeah, for real. That was pretty real.
it's all good.
So why'd you kind of like on her test, like right before we had to like basically give us the answer? Like she like do the problem, and then be like,
Let's do a little practice and it'll say the exact question. Which like I'm not complaining, but.
yeah, I'm not complaining at all.
Move on.
I like how you just have like paper right here.
We have the perfect amount of time to finish this. Step 1, write a balanced equation.
Phosphoric acid is HPO4.
No. Phosphoric means it had to come from phosphate. So you probably need your periodic table. Okay. I think we have now officially reached the end of CP Chem.
Is this a double? Wait, so is this double? Okay.
Well, we haven't done like the alcohols and stuff.
We don't do organics here. So,
So then,
yeah.
Oh, okay, wait, doesn't matter which
Huh?
does it matter which side you put?
Bro.
It doesn't matter which reactant comes first.
But okay.
However you want to write the order of the reactants is fine. That is hydrophosphoric acid,
Yeah.
not phosphoric acid.
I know, I was about to say that when I was looking at it.
Reactants are looking good. That is not correct. It's also that one. So I would check that. Looking at balanced equations right now. It's a good start. Good start. It's like a good start. I'm going to pause my screen while I start my work. If it's not hydro, there has to be no.
Right, but does it have to start with
it's on the thing, dude.
Phosphoric
Oh, it's
had to come from
On
phos.
here, it has the original.
Oh, it's also, is it all? Phosphoric had to come from phosphate, which is the back of the blue.
Lucy, the equation is on the yellow paper. You could just.
I like the
It's she likes the process. It's fine.
Bro, this is gonna take more than 5 minutes.
Yeah.
First check step. Balanced equation.
I haven't even got.
No. Oh, wait, yeah. We're right.
Guys,
We're right.
this is why you have to run through the whole thing.
The fact that you switched HCl and.
The order doesn't matter.
Yeah.
You could have had Ba3PO42 plus HCl.
Let's go,
There we
let's
go.
go, let's go, let's go. Okay.
There's your first check. Next step, determine your limiting reactant. Teaching my honors freshman dimensional analysis today. Isn't that so cute? Yeah. It's the very beginning of this. The journey begins today.
So you'll know
I
what
remember
JK
that.
is.
Yeah.
I remember when you know that.
Stop.
My dad thought that was so funny, the JK thing.
Good.
He cackled out loud.
Do you have your limiting reactant determined?
Yes.
Here's my next check step. Was it BaCl2? Are we okay with the limiting reactant, how I'm doing that?
Yes.
Because if you're not, you need to say something.
Yes.
No, yeah, I got it.
Okay. Because for every 1 mole of this, I need 1.5 moles worth of this. So for every 1 mole of this, I need 1.5 times this of this. Well, I know 1.5 times this is at least more than 0.3, right? Do I have 0.3 here? No. Okay, keep going. I need to pause. Also, that handwriting for me is pretty dang good.
It really is.
Like that is first day of Stoic. It's just a good handwriting day.
Yes.
Why did I pick such a long compound to write out? Ba3PO42. That's such a pain in Stoic to write out. Do we have excess?
Yeah.
It's so satisfying when you get to the end and like it matches. Like yes.
Is it supposed to happen?
I'm saying yeah, like it's probably gonna match what I have. Like when you see my excess
Oh.
and your excess, when it matches, you'll be
I
like
thought
yes.
you meant like it was like a perfect match, and I was like, I feel like that's not.
I want to check my maximum.
I had 8.05 grams excess. I'm so sorry.
No, my eyes are just bad. No, my eyes.
We're gonna take this, the last 5 minutes of lab lunch tomorrow, one more step in order to do the lab. Because the last thing we would do is I will give you how much we actually got, and I'm gonna show you to do percent yield.
Can you read the number for the theory?
For theory, 59.09 grams in theory. And then I took my limiting reactant, I ran that to H3O4, H3PO4, that's how much was used. And I subtracted that from how much H3PO4 I started with to get my 8.05 grams excess.
You said lab lunch tomorrow?
Lab lunch tomorrow
Yep. And Thursday?
and Thursday. Yes.
And Friday?
No, not Friday.
I messed up.
Nice work today. Very nice work today.